Considering yourself, you're going to. Wow. Considering yourself, you're going to. Yeah. What? Yeah. Like a drive. Right? But it's fractional error you need, right? Oh, I have right there. All right, so yes, we're gonna wrap up. One of the you can do it near and well, again, A, B, C, or D. David, I can message answers that. If you didn't start yet, so if you pay attention. Only as Garali, you too. Everybody who online, Sarai and Kaylin. Work it out, message answer A, B, C, or D. Right? Okay. A, B, C, or D. And none of the above. None? All right, so let's see. Ideally, we should be working in the right SI units, but you'll recognize if I convert 0.5 to kilograms and then convert 12.5 to kilograms, you're gonna get the same thing. Right? So you don't necessarily have to. Plus 3 by the error in L all over this by 100%. Right? How much is that? I think the answer is 40. Online, anybody get anything? Check it and see. C, 14%. Kill it with them to be it and say it and then see. All right, nice. So the answer is 14%, right? Those who online, you can just press the camera and you'll be able to see the answer on board, right? See what you get. It up. All right. Just one more to do. Right, just one more. These are the 3 things that we kind of did so far. One more, and then we start resolving forces, right? I won't go too far into it because I'm going ahead. Green for whatever green was there. Now I'm considering of something. Yeah. That's one cell. Right? not too much trouble. You can do this last one. Down. Now come with the corner. TV. TV. I real blood. I travel. Right, so yeah, what quantity does it represent? P by Q over. But let's do it some other controls. And we're gonna start resolving forces. Yeah. Well, these are new questions. What are you gonna run?
ENS.
What's that?
ENS.
Oh, it did not start. What again?
Yeah.
Please, what again? What again? See? See? Right, so the masses will cancel off. Right, the meter cube will cancel. And you'll get ms to the minus 2. This is minus 1, so it becomes what, plus 1? So you get ms minus 1. B. Anybody else get that, boy? What get that, boy? All right, nice. So now that's a couple of multiple choice. Instead of someone else to do bulk, what we did to these yet, right? I think we can handle that one thing. All right. So let's take a look at resolving forces, right? Some of it in your handout, but we don't need that right now. Right, head of resolving forces.
What's that?
Oh. Anybody else can do it? Right, just take 2 minutes, some of these for those who here. Take 2 minutes and then open up the Google form and fill it out, please. One time should be good, once it like something to do, right? Ready? Google form. Okay, you input. What's that to do it? No, that's the LMS. Yeah, it's in the physics, it's in the physics group chat. Wait, Viraj, in any group chat? Anybody else here not in the group chat? Right, but in the same form, right, Viraj? It's the same form from Pure Maths, it's the same form. Just make sure you put your email, and that's the most important thing there, right?
Let's see.
Anybody else?
Let's.
All right, these were the answers here, right? I just put on the work, you know. Are you sure? If you need somebody else. All right. Let's go ahead. Go ahead. Give me a minute. Let's finish that up because I wouldn't. Right? Let's go ahead and go fast. Yeah, I think one. I did that. But if you select one subject, then clear. So we're not into everything on. All right. All right, so resolving forces, right? So a nice simple example is this, right? Think about if I have an object, right? And I have these two forces acting on it. What direction is the object's resultant force? Diagonal, right? That's the resultant force. And that force is at an angle to this horizontal, correct? So if I give you a force here, and the reverse should also be true. If I give you a force acting at an angle to the horizontal, and this force should have two components, a horizontal and a vertical component, right? So all we're gonna learn to do is just take a force acting at an angle to the horizontal and find its two components. That's okay? So we cannot do it in the reverse now, given the resultant force and acting to find its two components. That's okay? So if we have something like this, right? If we have a resultant force, sorry, a force at an angle theta to the horizontal, that force has two components, right? It has a horizontal component and it has a vertical component, right? So FH is the horizontal component, right? Is the horizontal component of F, and FB is the vertical component of F. Sorry, FB. All right, so those are your two components. How do we find them? Well, simple. If I were to take this, right? If I were to take this diagram here and convert it into a right angle triangle, here's theta, here's F. This side here is the horizontal component. This side here is your vertical component. The triangle formed as a right angle, right? And if you have to find any one of these, you're using trig ratios, right? Because most likely this is what you will have. So you use a trig ratio, right? So you can use sine theta. Sine theta is equal to opposite over hypotenuse. So you'll get FB to be F sine theta. That's okay. And if you use cos theta, you'll get adjacent over hypotenuse. Right? FH is equal to adjacent over hypotenuse. So FH is F cos theta. Right? So in short, the horizontal component is F cos theta. The vertical component in this case is F sine theta. Right? How do you learn this? Instead of having to learn it like this, here's what you can. Real simple, right? Cos is always give you what? Cos is always from the adjacent and the hypotenuse, right? And sine is always from the opposite and the hypotenuse. So if you look at the diagram and you figure out which of these forces is adjacent, you know which one is cos. right? And if you know the one that cuts, the next is automatically sine. You okay with that? What's the example here? Makes it make sense, right? Because horizontal will never always be cos. It'll vary, right? It's based on how the diagram looks out, how the force acting. So if I give you a quick example here, suppose I gave you a force of 40 newtons acting at an angle 30 degrees, right? Where is the horizontal and where is the vertical component? Horizontal is here and vertical is here, right? Without doing all of that. Horizontal component is what? Watch here, Olivia. Watch here, right? Horizontal, we have the force, we have the angle. Adjacent to the angle is horizontal component. So it means that the horizontal component is F cos theta. So that's 40 cos theta. That's okay? And if you figure out cos, then the next is sine. Right? One of the cos, the next will automatically become sine. Okay? So your main goal is really to figure out which of these is cos. Right? I'll give you an example here. I'll give you a next example where it wouldn't look like this, right? It'll be the other way around. Right? Look at this example here. What direction will be the components here? A force acting this way. So the components are where? Horizontal is to the right and vertical is upwards. Right? By looking at the diagram, which of the forces are adjacent to the angle? The vertical or the horizontal? The vertical. So it means that the vertical will be 30 cos 20. And if one is cos, the next is sine. Okay? So you don't have to go and draw a diagram and work them out. Just use the diagram that you have, figure out which is cos, next automatically sine. Okay? Please remember to include the direction correctly, right? Copy it down. Online, are you okay there? How was this? What did I get? What is it? The vector question. That comes a lot less. Right, so I can two, three, and move around. And I have one more choose. What is? How about who might take? Yeah. Right, so the problem now is that questions with we solving and things, we're going to have to cater for forces acting at an angle. Right, initially with this horizontal and vertical, now we have components to look at, right? Elijah, are you okay online? Katrina? Yeah. Hey, man, don't be a problem. Hey, nice to get in. See you o'clock.
No, you didn't see her.
I saw you
Where's
outside.
What was in here?
Well, yes, you walked with somebody down, so, and, just need to,
I mean, toss it on, so.
let's just, somewhere there, somewhere there. I thought it come back.
That's okay. Well, like a soup, can you really see no soup ends?
What do you want them?
Extend that you did not. There was. You know, still talk. A trouble, I would say.
Everything on that point. on the layer part of what you're recording, actually cut it up.
It's fucking real.
I can have pick up on the feet, no, it's not happy to go. See that thread on that first? Right, as dealing with forces, we need to be able to always, draw all the forces at an object, right? But when you apply maths, you will need this, right? Imagine applying, you know, apply. You don't have to apply math. This whole thing is module 3 units. I don't know what happened on the bottom. Just the other. What's that? Yes, I got somewhere wrong in I didn't watch it. Similar to Ready? Can I take off the left hand side? Right, so let's give me two diagrams. All I want you to do for me is to find the two components, right? That's 30 degrees there, right? 30. And this is 40 newtons. And then let's change it slightly. Right, this is 100 newtons. And this is 45 degrees. Right? In both cases, find the horizontal and the vertical components. Only I couldn't figure out what are the cases and it was right. Right, remember you have to put the direction on the forces, right? So what direction the horizontal forces acting here? To the left or to the right? To the left. And what direction will the vertical force acting up or down? right? Go ahead, take your time. Work out the horizontal, work out the vertical components. Make sure you shoot it direction, right? That's why I've come to the arrow. Right, for those who came to class late, I'm gonna show you quick there. Right, so the angle is here, right? The angle is here, right? And adjacent to the angle is which one? Horizontal, right? So once you figure out which force is adjacent to the angle, right? It means that cos will be that particular one, so that will be 40 cos 30. Right? All you have to do is figure out which one is adjacent. Next will be 40 sine 2. Oh, by the way, should actually work these out. Huh? This is 20 and this one is what? What's the exact? Give me the value with the root. Like 20 root 3 or something? 20 root. 20 root 3. Oh, where would we think of these? I know anyway, so
Exactly because I want you mad.
right, and you have two forces here. One. Right, I didn't put minus and plus because I showed you direction, right? If it didn't do that, then maybe you had to show one direction positive and one negative. Okay, but I didn't do that. I showed you direction in diagram. What about here? Aris? To the vertical is to the right. Horizontal is. Horizontal is to the right and vertical is downward. Right? Which of the components is adjacent? Vertical, right? So enough. So the vertical component is adjacent. So that will be 100 cos 45. And the next will automatically become 100 sine 45. Okay? This is what? Huh? 50 or 2? Yeah, it should be the same, right? Online, any questions? With resolving forces? Online, are you okay? David? Okay. All right, so that's the way we find, that's the way we resolve forces, right? Resolving simply means you're taking a force and you're finding its components, right? Now we want to be able to find the resultant force. Right? We want to be able to find the resultant force acting on an object. And what is the definition for resultant force? The definition for resultant force is what? The algebraic sum of all the forces acting on a point.
Yeah.
All right.
Yeah.
All right. Then it knows, right? But we'll focus on the example on this here, right? Let me just go over this in case all of forget. How you find the resultant force here? What's the resultant force here? F1 plus, right? It's the algebraic sum. So it means that one direction positive, next is negative, right? So the algebraic sum of all the forces acting will give you the resultant force. What about here? Same principle. You have F1 and you have F2. If I consider down as positive, up as negative, the resultant force is minus F1 plus F2. Online, are you okay, Elijah? Are you okay with us? Yeah? Yeah. But the case I am interested in is when the forces act like this. Right? Suppose they had F1 and F2. Where is the resultant force again? All right. How do we find that resultant force? That's Pythagoras theorem, right? Square root of F1 squared plus F2 squared. Right? So I'm going to give you scenarios, right? I'm going to give you scenarios where the forces end up looking like this. Right? Not really this so much. Okay. Actually, let me give you one combined. F, so which one? Well, I said up is positive, down is negative. I said up is negative, down is positive. It don't matter. If you say positive and negative, it just your sign will be different, but you'll end up with the same resultant force in the same direction. Right? My sign convention here plus and here minus. It don't matter. Right? All right, so that's the way you find resultant force. Before I give you a tricky scenario, try this one here for me. Right, try this example. It's form four stuff, right? The form four is just do. Form four is just do this. My favor, find the resultant force here. Each one of these, find the resultant force. What do you do first again? What do you do first? Right, so you resolve horizontally first, then you resolve everything, and then it should look like this.
Yeah,
And then you use Pythagoras.
yeah.
Okay. One thing missing here is this. Yeah, you gotta be able to find alpha, right?
Yeah.
Yeah. What is find alpha? No, tan.
Same thing.
Tan inverse F1 over. In this case. Right, so see if you remember what to do. Resolve horizontally, then resolve vertically, and then find the result. Try that. Going next class with the and lovely. Go next one. It's not anything lovely. Attention, le dit, pas Huh? Oh, no. General. I see. Well, let me have time to reach over. You thought sorry. Huh? Don't stand up. Oh, 7 o'clock. I can teach our next class, though. Yeah, if you go smart. Start for me. Here, here. People talk here, boy, right? Yeah, can I teach our class, boy? Turn on smart here. Yeah. I'm good to you. Huh? How about you? What do you mean, right? Right, finding resultant. Are they got true? That- Finish? Why you tan? Because I have, well, you can use sign up because if you want to know. But I use tan because I using these two forces here. F1 and F. Yeah, so the reason I use alpha is that I don't need, let's say you work on F wrong. Then you will use that wrong value on the alpha wrong. So I use F1 and F2. Because remember, F1 is here. This F1 can also be right here. Remember the diagram I showed you a little while ago? It's called triangular forces. Those three forces form that triangle. Right? So your first step should look like this. When you find the when you resolve vertically, you'll end up with 8 newtons downwards. When you resolve horizontally, you'll end up with 6 newtons to the left. Okay? So your resultant is here. Right? So your resultant force is what? The square root of 6 squared plus 8 squared. Okay? And that'll give you 10. Right? And again, what's important is that we find alpha. Double. So I simplify this diagram to this, right? So I get 8 down and 6 to the left. And then I found the resultant here using Pythagoras. But you have to give them the angle. I am using the angulars here. So that will be tan inverse opposite over adjacent. What is that? 53.1. 53.1. Viraj, you okay with that? Ma'am Nayan? Right now, to combine everything that we did so far. Watch this here, right? If I give you an object and the object has these 3 forces active, 4 newtons here, 2 newtons here, and instead of it acting vertically or horizontally, I'm giving you a force at an angle, let's say 6 newtons, and the angle is 30 degrees. And I want you to find resultant force here. What you'll do first, Reese? There's no way you use that, right? What you use that? For that. So what you will do? Right. So find the horizontal component of this 6.
Yeah.
And then find the vertical component of this 6. Then rub off that and then work it out just like that.
Yeah.
That's okay? So find the 2 components here and then we'll go it down. You okay with that? Try that quick. Right online, all you're doing is taking the 6 newtons and you're resolving it horizontally and vertically. And then you can take up this and just focus on 1, 2, 3, 4, just like that example there and do it out.
Yes, we believe him. I think it's starting, but I don't wanna exclude my value. Nothing.
Well, and our funds were very good. So basically, they use it like only what you do, and then like the I inspect that one and I find the same. So then I propose like only particular one.
Well, that's not the whole.
I do.
Also the routine, they don't come to school.
Yeah.
First, complaint.
Yeah.
I got first, complaint on the term, not getting this right.
Look red. Prayers, even though I'm seeing.
No.
Which one? New ones?
One second.
So you got you.
People have two bars, somebody put those.
You got you.
Yeah, that's
So,
it.
the girls flying on that don't you know more? Basic studies.
He does complain to us. A little bit of I had to see it.
Huh? Okay, so there was section where that's the point. Now you can't use that. What is the detail of the body section? When it's not when. Sorry, that I give miles.
Not there.
Huh? No. So that game I think we're gonna be like, oh, when it's stopping on, okay. We have picked up. What, that one you like cancel? Yeah. And I feel like plenty. So I think that one side.
Big what is really 6 foot away from the yeah.
Is it?
Yeah.
But he, what's anything in the middle? And I think I put it made up for that.
Yeah, I don't know what they're gonna drop. It's not that.
What the middle.
No, but that's because I get this maybe 2
He's the start.
Yeah,
He's the start. Wanna get you?
Yeah.
Hopefully, the results, right, and now you just make check like that. Focus on everything horizontally, everything vertically, and then you'll get that down like that. Right? Huh? When you get what? So when you do the first thing, right? Here's 4. Here's 2, right? When you resolve here, this will be 6 cos 30. When you resolve here, it will be 6 sin 30. That's okay? Now this diagram just like that. So you're resolving horizontally and you're resolving horizontally and you're resolving vertically. So you have one more diagram to get, right? When you resolve 6 cos 30 and 4 vertically, you'll end up with 1 acting downwards. Okay, you'll get 4 minus this. And then here, which one? How much? Give me the exact one. This is 3 minus 2. So it will be 3 root 3 minus 2. Right? I try not to round up too much. And then the resultant forces here. Right? So online, in case you get lost, when you resolve the 6 Newton force here and here, you will get this diagram here. And when you finish, resolve horizontally, and you will get this minus this, resolve vertically, and you will get 6 sine 30 minus 4, which is 1 acting downward. Right? And then when you reach here, find the resultant force. That is square root of 1 squared plus 3 root 3 minus 2 squared. If you want to round up here, that's okay, right? I just try not to round up too much. And the resultant force, you can round up here, obviously. 3.35 Newton. That's the resultant force, right? Right? And of course, you need your angle. Right? Your angle will be tan inverse opposite over 3 root 3 minus. Double? This minus this. I didn't want to round off now, but if you want to round off, you can round off. Right? Online, any questions? Katrina got 17.5. Anybody else get us? 17.37, so 17.4, right? Yeah. Everybody okay with that? Anybody confused online? Wait, I give a solution. Everybody okay online there? Ask around it. You okay, right? Yeah, you're okay. Right, before we look at equilibrium conditions, let's do our next one. Are you okay with this? I gave it 2 forces. I gave it 2 forces on an angle now. In fact, let's do one more like this. And that quick. And I'll give you one with just 2 and that's it. For this, I'm going to show you our next scenario. Take your time, find the result out. At an angle here, 40 degrees. At an angle.
So, check. Take this question. Take it. Yeah, I didn't.
That's it. If you have to round up, go ahead and round up, right? And if you have bad angle this time. It might be forced it might be forced to result round up. If you resolve here, if you resolve 10 newtons horizontally, that will be 10 cos 40. This will automatically become 10 sine 40. Right? Once you figure out cos, sine becomes easy. Right? Then you have 8 minus this and you have 10 minus this. Right? So your second diagram. What is 10 sine 40 over here? 6.4. And what is 10 cos 40? 7.6. Nice. So this is bigger than, remember, ignore this, you're doing this anymore. Right? This is bigger than this, so it will go upwards. That'll be 8 minus 6.4. Right? Which is bigger? This is bigger than this. So this will be 7.6 minus 5. And our resultant will be right here. So resultant will be the square root of, how much is this? This is 1.6. And this will be 2.6. Altogether, 1.6 here, 2.6. Right, so what's the resultant force? How much? 3.09. How many is the time? Oh, 3.09, nice. And then you find the angle. Right? Then you find the angle. Right? Alpha is equal to tan inverse 1.6 over 2.6. Right? Always give them magnitude, direction. What is that? 50.5. How about 50.6? Right here. How about double? Any questions online? You all got those values there? Right, let's do one more where I'll change the scenario a little bit, right? Right, and all I'm going to change is instead of giving you 1 force, I'll give you 2. Right, and then we can just shift to the rules on equilibrium, right? Right, now please find a result on force. Last one like that, right? Once you catch it, they're okay. Take your time, huh? Take your time and construct a different second diagram. Might have two there, very soon what happen, right? Right, remember we do want a hard copy of part people, where my guy name is someone, right? There you go. Right, in numbers. Take your time with this one because you have two sets of resolving to do here, right? Right, resolve the 5 newtons and then resolve 10 newtons. Right, just a quick reminder. When you resolve the 10 newtons, it will have a vertical component. It will also have a horizontal. When you resolve this 5 newtons, it will have a horizontal. It will also have a vertical. So you're going to end up with 2 vertical here, 1 down here, 2 horizontal here, 1 here. Okay? Voilà. Huh? Right, so this force is adjacent to the angle, so that'll be 5 cos 10 degrees. Right, this one obviously, that'll be the 5 sine 10 degrees. Right, we also have the 6 Newton acting here. Right, We also have the 6 newtons acting here. You okay with that? When you resolve here, when you resolve 10 newtons vertically, cos or sine? Cos, right? So that'll be 10 cos 20. And then it means that the horizontal will be 10 sine 20, right? Once you figure out the vertical, once you figure out cos, the next is automatically sine. Then you have 4 newtons here. So you have to include that here. Okay, diagram should look like that. Two vertical, 1 vertical here, 2 horizontal here, 1 horizontal here. Right? But follow what I did. So now you have to resolve these 2 minus this, these 2 minus. Right? Then finally resolve that. Okay. So by introducing the extra force, the extra 2 components, you end up with something looking like this, right? Online, just saw what I did, right? I just simply resolved twice, right? This here and here, this here and here. So I end up with 2 up here, 1 down here, 2 to the left, 1 here. Yeah. Right? Just help me out here now, please. When you add these 2 and minuses, like that.
2.5.
Of what? Huh? Also, this bigger than the sum of 2 of them. How much?
2.5.
2.5. Add these 2. 0.5 again. Okay. Anybody else get that? 2.5. 2.5. Yeah. So your result. Perfect.
Oh, that is,
Now,
yeah.
right? Huh?
You cannot.
Right. Else. So resultant is the square root of 2.5 squared. 2.5 squared plus 2.5. What is it? 2.5? Correct? What you got this right? Y'all got this for values? Oh, anybody got this online? 2.5, 2.5? You got that? So the square root is this one. How much? 3.54. Anybody else got that? Katrina, you got these for values here, 2.5 and 2.5, right? Yeah. And the square root is how much? What is square root of this? For this,
It's 5 and 2.
for which one? Oh, 5 root 2, well, which is, well, we don't round up for it, so they can very round up, but 3.54. Because we already round up, right? So no need to, right? And then alpha will be how much? 45, right? Because it's even on both sides. Right. And one last thing, right? Let's get a different scenario. Okay. Next thing we look at equilibrium. What do you think will change if I said that this system in equilibrium? If I said this system here is in equilibrium, what will change here? The resultant should be what? 0, right? So if this system in equilibrium, the resultant should be 0. Right. There's just one more scenario I want to show you before we wrap up, right? Right, all the time we have been considering, we have been looking at this, right? Taking the horizontal ground and applying a force at an angle to the horizontal. That's okay? But suppose I gave you a scenario like this. You have the ground, of course, and I am going to take a plank and incline the plank at an angle. Right? So the plank is at an angle. And then I'm going to put object on top here. What will be the force acting on the object? Weight, of course, right? Weight acting vertically downwards. And of course, there's a next force here, contact force, for the reaction force, right? Right. What will happen if I just leave that block on top of that inclined plank? It will slide down, right? And the only reason it will slide down is that it must have a force pulling downwards, right? Must have a force there, right? What is that force pulling downwards? Huh? Wait, no, that's not the sun, that's reaction force, contact force. What is just pulling it downwards? Gotta be the weight, right? But it can be W. It has to be a part of W or a component of W. Right? So we have to be able to resolve W along the plane and vertically. So let's call this perpendicular to the plane, and let's call this one parallel to the plane. Right? Plane meaning this plank here. Okay? So we have two things to look at. How do we get this, number one, and how do we get this? Right? This force is what gives it the normal reaction. This is what gives it the force to pull it downwards. And these two forces are components of the weight. Okay? Right? This one here, I'll show you how to get it just now, but actually, I'm already good enough. How are we getting now? How are we going to resolve W? How are we going to resolve W parallel and perpendicular to the plane? Obviously, one is sine and one cos, right? How will you figure that out? Yeah. The weight is the hypotenuse. Then you have your parallel component here, 90 degrees here because it had to be 90 to the perpendicular force. Correct? But the problem is where the angle is going. Where is alpha? So I kind of reconstruct a right angle triangle here for you. But alpha is out here. Anybody can tell me how to get alpha? So what you see first? This diagram here is a right. Sorry, online. This diagram here is a right angle triangle, right? Here's alpha. Here's 90. So how much is here? Huh?
Consider that.
You see that, right?
Minus.
Alright, let's pretend in some numbers. Weight diagram. Yeah. No, weight acting vertically downwards. Perpendicular means perpendicular to this plane, right? Let's use numbers. If here is 40 and here is 90, how much is here? If here is 40, here's how much? Which is 50, right? Here's 50. Are you okay with that? So how much is here? The small piece in the middle. Here's a right angle triangle here. Here to here is 90. I don't want to draw it up because I want to rub it off. Right? Here to here is 90, right? So if here is 50, how much is here? 40. So this is the same as this, huh? So how much is here? Alpha. If here's alpha as well. Right? So what does that mean? Opposite, adjacent. So this is W sine alpha, this is W cos alpha. Okay? But to be honest, you don't really have to do all that. Okay, let's learn this. Right? Because I know what a scenario is always like this. Okay? Are you okay with that? Alright, so what's important is if you see a diagram like this, you have to be able to put all the forces acting. Right? So the forces acting are weight and the reaction force. And the component of weight acting parallel to the plane is sine and perpendicular. Alright? And I said it, right? This diagram in the notes was so to understand where this came from, right? What's all what I write it from?
I didn't get it. I didn't get it.
Huh?
I didn't get it.
I didn't send any notes. I didn't send you what you want to know. Okay, I'll send it down. Right, it will also be on the element on the LMS as well. That's why I want you all to fill out that form, right? Okay, I will send you module 1 for you. Yeah. Yeah, but you will send it by email.